The next question says, which test cases are written first, black box or white box? So in black box testing, we begin to write our black box test cases, okay? In white box testing, the developer, for example, might write his test cases using test-driven development, for example, okay? Or the tester might write them in some cases. But which are written first? And this is a general question. He didn't ask you about sequential life cycles like waterfall or V model, or on the other hand, agile life cycles like Scrum. So we will answer the question in a general way also. So let's take the waterfall and the V model as an example. So for example, in the V model, we have the requirements, then the design, then coding, testing, unit testing, integration testing, system testing, and acceptance testing. So this is the order of execution. But when we are talking about designing test cases, when we explained the V model, we said that once we write the requirements, we begin to plan our acceptance testing. We begin to write our acceptance testing test plan. Then we begin to design our test cases for acceptance testing. The same with the SRS. After writing it, we begin to plan our system testing and write our system testing test plan. Then in the design, we begin to write our integration testing test cases, then our unit testing test cases. So when we are talking about designing test cases, the order goes like this. We begin to write the test cases for acceptance testing, then system testing, then integration testing, then unit testing, okay? And when we execute the test cases, we execute unit testing test cases, then integration testing test cases, then system testing test cases, then acceptance testing test cases. And here he is asking about writing the test cases, and this is designing the test cases. So the black box test cases are written first. Why? Because most of the time, the test cases that are written for acceptance testing and system testing are black box, okay? On the other hand, most of the time, the test cases for unit testing and integration testing are white box. So the correct order is that black box test cases are written first because their test bases are the user requirements and the SRS, while the test bases for white box test cases are detailed design and component specification. But like we said, this is a general answer. This doesn't happen in all projects, okay? If we are talking about, for example, an agile project and we divided our project into iterations, so in the iteration, the tester might be writing some test cases for system testing at the same time while the developer is writing test cases for unit testing. The next question says, what is use case testing? Like we explained, we have many black box test techniques. One of them was use case testing. So in order to explain what is use case testing, we need first to explain what is a use case. So the use case is a description of a particular use of the system by an actor or a user of the system. So we have an actor who does some interactions with the system. Each use case describes the interactions the actor has with the system in order to achieve a specific task, or at least produce something of value to the user. The actors are generally people, which are users, but they may also be other systems. So like we said earlier, if we have two systems, so in this case, one system is interacting with the other one, okay? And in this case, we write use cases for them. And when we test those use cases, we use system integration testing. So like we see here, for example, this is a system like a chatting system, and this is a user who interacts with the system. He begins to log in, enters his username, and does some steps. We have also a remote system or a remote user who accesses the system using a remote system. So here we have two systems interacting with each other, and we have two types of users. And this is called a use case diagram. We also have use case table. We explain the system in a table. So use case testing is a test technique that helps us in identifying all the test cases in this system. So like we see here, it is a technique that helps us identify test cases that exercise the whole system on a transaction by transaction basis from start to finish. The next question says, what is the difference between equivalence partitioning and boundary value analysis? We have 5 major black box test techniques, which are equivalence partitioning, boundary value analysis, decision table, state transition testing, and use case testing. Equivalence partitioning and boundary value analysis deal with numbers, like we said, okay? They deal with range of numbers. So what is the main difference between them? Equivalence partitioning divides data into partitions, also known as equivalence classes, in such a way that all the members of a given partition are expected to be processed in the same way. So we divide our system into partitions, for example males and females, or based on age, for example like under 18 years, 18 to 21 years, and so on. And in order to test the system using equivalence partitioning, we use one test case per partition. So from each partition, like this example, we take one test case. So here, for example, the invalid partition is 0, so we will test 0. The valid partition is from 1 to 1000, we will test any value from it. The invalid partition is 1001 or more, so we will test any value more than 1000. In boundary value analysis, we have the same system, okay? We have the same partitions, but it is an extension of equivalence partitioning, and it can only be used when the partition is ordered, consisting of numeric or sequential data. So for example, if we have two partitions like we said, males and females, in this case we can use equivalence partitioning, okay? We will take one male and one female, but we can't use boundary value analysis, okay? Because the partitions don't have a start and an end. They don't consist of numeric or sequential data. But if we have numeric partitions like this one, which begins at 1 and ends at 1000, in this case we can apply boundary value analysis. And the values that will be tested using boundary value analysis are the minimum and maximum values, or the first and last value of each partition. So why do we use boundary value analysis? Because the behavior at the boundaries of equivalence partitions is more likely to be incorrect than behavior within the partitions. So in this system, for example, it is more likely to find a defect if you test at 1 or 1000 than you test at, for example, 500 or 400. When do we prefer boundary value analysis? Like we said, if the partition is ordered and it's consisting of numeric or sequential data, and also if we need to have higher quality of our system. On the other hand, equivalence partitioning is preferred if the partition is not ordered and it doesn't consist of numeric or sequential data, and also if we don't have enough time to specify the boundaries of each partition.